next reaction we'll talk about is elimination reaction. So in elimination reaction, we are eliminating some molecules, okay? The molecules we eliminate in this kind of reactions could either be water, it could be ammonia, it could be HX, depending on the reaction you are performing, right? So these things are eliminated in the form of, you can eliminate this in the form of hydrogen and what? Hydroxide ion. You can eliminate this in the form of hydrogen and amine group. Then you can eliminate this in the form of hydrogen and X. So most elimination reactions lead to the formation of an alkane, okay? Most of the elimination we're going to look at this your level will lead to the formation of an alkane, okay? So in elimination reaction, we are going to focus on 1,2 elimination, okay? We are going to focus on 1,2 elimination. So 1,2 elimination simply means eliminating, if you have carbon to carbon, you eliminate one parameter from here and eliminate one parameter from the adjacent carbon. So this elimination is called 1,2 elimination. So this 1,2 elimination is an important elimination because we use it to synthesize alkanes. So we can get alkanes from this elimination. So the process of removing water from a substance to get an alkane is called dehydration, okay? It's called dehydration. Why this is called dehydrohalogenation. So the removal of HX is called dehydration. So simple reactions such as dehydration and dehydrohalogenation follows an elimination pattern, okay? So inside elimination reaction, we have two mechanisms or more than two. We're going to focus on only two mechanisms. We have more than two. We have E1, E2, and we have E1CB and the E2CB, but we're going to focus on the E1 and the E2 elimination mechanism. So inside elimination reaction, we have what we call the E1 and the what? E2. So we are going to look at the mechanism or how this elimination reaction happens so as to form these alkanes we are talking about. So today we'll be looking at E1 mechanism, okay? So first of all, what is E1? E1 simply stands for elimination and what? Unimolecular. Just like SN1 and SN2, the one is unimolecular, okay? So if it is unimolecular, it means that the rate will be dependent on just one thing, okay? Which is the what? The substrate. In the E1 mechanism, the substrate is the alkyl group and the leaving group. Remember that for elimination reaction, something will leave, okay? Two things will leave, okay? So in the substrate, the leaving group will go out, okay? So the point where this leaving group is leaving the substrate is what we call the rate determining step. So the rate determining step of the mechanism depends on the decomposition of the single molecular species. Overall, okay, that it stops here. So the rate determining step for this E1 mechanism depends on this, how this one goes, when this one leaves, okay? So now generally for E1 mechanism, there are two steps. It's a multi-step reaction, just like the SN1 reaction. For E1 mechanism, it's a multi-step. It involves, first of all, the loss of the leaving group. The leaving group will leave first. Now, when the leaving group leaves, it generates a carbocation, just like you know. When the leaving group goes out, a carbocation is generated. Now, the next thing that will happen is the loss of a proton. Okay? So, if the leaving group goes and the proton goes, then there will be a formation of a pi bond, which I told you that most times, most elimination reactions leads to the formation of what? A double bond, which is what? An alkane. So let's look at an example. Now, let's assume that we have something like this. Look at this molecule. Let's say we have something like this. Now, for this reaction, what will happen first? If this reaction wants to follow an E1 mechanism of elimination, what will happen first? Look at the leaving group. Look at the leaving group. The leaving group will leave first. That is, it will leave. So the leaving group is leaving. Now the point where this leaving group is leaving is called the what? The rate determining what? Step. This is the rate determining step. Okay? And this step is a slow step. The rate determining step takes time, it's a slow step. So when this guy leaves, what happens? A carbocation is formed. Is that not so? Watch, I just rearrange this, okay? A carbocation is formed. That's a positive charge is formed here. Is that not so? So if a positive charge is being formed here, the next step for this reaction is the loss of the proton. So one of the protons from this alpha carbon, okay, will leave. Now remember that this is connected like this. Remember it is like this. Remember we have this and we have this. Okay, so what happens is that you are going to use a base to deprotonate. Deprotonate means remove one proton from here. So I'm going to deprotonate. It's called deprotonation. Deprotonation simply means eliminate one of the hydrogens from the carbon that is beside this other carbon with the positive charge. So I will quickly, a base here will deprotonate. Let's deprotonate this. Let's deprotonate this one. It's much more easier. So if I deprotonate, if I remove this guy, remember there is a pi bond here. This pi bond here will come here and stabilize this charge. So that I'm going to have CH3. This pi bond will come here. So I'm going to have C double bond CH2. Because remember I've removed one of the hydrogen here. So I have two more left here. Then I still have what? CH3. So notice that if you undergo an E1 mechanism for this compound is tert butyl bromide. This compound is called tert butyl bromide. Okay? Or you can call it 1, 2, 3. You can call it 2-bromo 2-methyl propane. Okay? So if you undergo an E1 mechanism for this, you have this compound, and this compound here is 2-methyl propane. So have you seen how we generated an alkane from the substrate? So this pattern of reaction, this mechanism of reaction is what we call the E1 mechanism. Because why is it E1? In E1, the leaving group will go out first, forming the carbocation. The carbocation will now what? The carbocation will now be deprotonated. The hydrogen from the methyl carbocation here will be deprotonated, and then the pi bond, this bond here goes up here and forms or stabilizes this charge to have this double bond. So this mechanism of reaction is what we call the E1 mechanism. Okay? So the next we talk about now is E2. So you can now see the difference. You will now see the difference between E1 and E2. Okay? Now, for E1, I want to say something again. For E1, the more stable the carbocation, the faster it reacts to E1 mechanism. So stable tertiary carbocation reacts fastest to what? E1. So most students will think that the more stable, the lesser the reaction. No. For this one, the more stable the carbocation, the faster the reaction. So if this carbocation is not stable, it will rearrange itself, just like I told you. But I'm not going to go into details because the course outline does not involve us going into the course. If I had gone into details, you will see how carbocations can rearrange to become more stable, undergoing what we call a 1,2 hydride shift or 1,2 alkyl shift that will stabilize it and then make it more stable. Then it will now further react to what? To E1. Okay, so I would have also talked about the Sazef rule, but I don't think this there's a rule we call the Sazef rule. Okay, the Sazef rule. So, but I won't talk about it because I don't think it covers this outline. You can also apply the Sazef rule in this E1 mechanism for you to know where to deprotonate and where not to what? Deprotonate. Okay, so deprotonation depends. For you to undergo deprotonation in a compound that has two different alkyl group by the side, you have to obey the Sazef rule, which says that deprotonation or dehydration will occur from the side that has more alkyl substituents. But I'm not going to talk about that. But I'm just explaining E1 and E2 for basics. Okay. So today we're talking about E2. Okay. Remember I talked about E1 mechanism. For E1 mechanism, it is a stepwise reaction. Okay. Loss of the leaving group, then the carbocation is being formed, and then the carbocation is being deprotonated by the base to form the alkane. Now, for the E2 mechanism, E2 is a concerted reaction. That is, it means both the base and the leaving group and the substrate are all reacting at the same time. Just remember, concerted, the word concerted simply means, where is the word concerted? The word concerted, where did I concerted here? Let me find it. Okay, I didn't use the word, okay, concerted, yeah. The word concerted simply means that both the base and the substrate are all reacting. Okay, now let's read what's on the board here. We say that E2 indicates, of course, you know, it's elimination bimolecular. Why is it bimolecular? It is bimolecular because both the base and the substrate determines the rate of the reaction. Okay, so this implies that the rate determining step involves the interaction between these two species, okay, the base and the what? Organic substrate. So the pathway is a concerted pathway. Why is it concerted? It is concerted because as the base is deprotonating or removing this proton, the leaving group is also leaving, thereby forming the formation of a pi bond. Let me show you. Now, if I have something like this, watch. If I have something like this, let's say I have something like this. Let's say I have hydrogen, 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 and I have halogen. Now, what this I'm trying to show you is that if the base is deprotonating this one will come here, then this one will leave, so that I will have something like this. Remember, this is for this, okay? Then while this one goes out, the double bond here comes, the bond here comes here and form the double bond here. So I have this CH2 here. So have you seen how I have deprotonated and then removed the leaving group? So I have finally just removed HBr from here to form this guy. So this reaction can also be called dehydrohalogenation. And this mechanism of reaction is what we call the E2 mechanism, where both the base and the leaving group are all coming in, are all removing and leaving at the same time. So we are going to use another example to illustrate this aside this, okay? So quickly, let's look at another example, okay? So let's say we have something like this. Let's say we have something like this. And we are treating this with hydroxide ion. So what will happen here? Remember that this reaction is a concerted reaction. Everything will take place in one place, okay? So I'm going to take this here. I have CH3, C having H, having H, having C, having H, having Br, and have CH3. So what happens here? I have the OH. So this OH group here, will deprotonate this one. And when it takes this one, this bond comes here, and this one leaves. Okay? So that what I will have as the product of this reaction will become, okay, let me write the answer here. So the product of this reaction will become CH3, C. Remember this one has gone, so I have a double bond here. Let me just say CH, double bond, CH, CH3. So this is the product of this reaction. So what happened here is simple. The reaction is a concerted reaction. So both the base and the leaving group are all leaving. So how do I show that the base and the leaving group are leaving? So look at this OH. The OH is taking the H, and the bond here is coming down here to form this double bond you are seeing here. So this H is still this H here, this H here is still this H here. Then the Br leaves, okay? So you have plus the Br minus. So that is what is happening here. So in this reaction is an E2 mechanism because both the leaving group and and the hydrogen are being removed simultaneously. Okay, so that is the mechanism for this E2 mechanism. So we are going to look at the comparison. Compare these two reactions, E1 and E2, so you can be able to see the differences between these two reactions.